says the town of Hammond is considering the purchase of a four-sided piece of property to be used for a playground. The dimensions of the property are given below. Find the area of the property in square feet. Notice it's not a rectangle. A reminder back from, I don't know, third, fourth grade. It's a rectangle, length times width, you got the area. Now we can approximate the area. Is it a trapezoid? Can we use the area formula for a trapezoid? Can anybody, let's see how much you remember about geometry. Can anybody tell me how I know this is not a trapezoid? Let me draw a trapezoid. This might be a good review for you for geometry. It might be something you need to remember. What's true about these two lines in a trapezoid? The bases. Parallel. If they're parallel, you remember that whole thing about parallel lines cut by transversals and all that? There's your trapezoid. Parallel lines cut by transversal, you've got certain angles that are congruent, right? Like this angle and this angle. Those are corresponding angles. Those would be congruent. These two angles are congruent. These two angles, all four of those that I put dots on are congruent. Now, what's the relationship between the other four angles? What's true about these two angles? Supplementary. They add up to 180, straight line. So if those two are supplementary, well, these two would be supplementary as well. So these two, you could use that relationship. These two are actually supplementary. This angle and this angle in a trapezoid will always be supplementary. Same way on the other side. Parallel lines cut by transversal. This angle will always be supplementary. This is not a trapezoid. 89 degrees, 87. Actually, it's closer to being supplementary this way, isn't it? It's nearly a trapezoid with these two lines being parallel. And it's so close, if you wanted to, you could estimate it, because if you did, let's see, if you do 92 and 87.2, 92.3, that's 179.5. Let's see how close that is to being a trapezoid. Same thing here. 91.5 and 89, that's 180.5. That's pretty much a trapezoid. Okay, and you could again estimate. You could estimate this formula by doing the area of a trapezoid. Area equals 1/2 times height times base 1 plus base 2, to where it's not like it looks. These would actually be your bases. Height-wise, though, well, you don't really have a height. This would be close to being a height because it's nearly perpendicular. So it's just, you're not going to get an exact answer, but you could get an approximate answer by using that. Now let's talk about exact. Reminder of your formula. When you're dealing with a triangle, you can find the area of a triangle using trigonometry by taking, I'm going to call this S1 and S2 and alpha. If you have that relationship, that side angle side relationship, then you can find the area of that triangle by doing area equals 1/2 S1 S2 times the sine of alpha. And we've got that relationship here. You've got what this actual shape is. It's just two triangles. We're going to split it right down the middle here. And we're going to find the area of triangle 1, the area of triangle 2, and simply add those two areas together. That's how we're going to work it. Pretty easy problem. Let's do this. We'll work it both ways because I'm just curious how close that trapezoid formula would come to the actual area. So area of triangle 1. Area 1 is going to equal 1/2. You've got two side lengths here and here, and you've got an angle in the middle. You've got that side angle side relationship, so you've got 1/2 of 93.5 times your other leg, which is 148.7, times the sine of the included angle, which is 91.5. And y'all be typing that in as I write down area 2. Area 2, your other triangle, you're given this leg, and the included angle. That's what we're going to use. So area 2 is going to equal 1/2. Leg 1, which is 100.5. Leg 2, which is 155.4. Times the sine of the included angle, which is 87.2. Back to your first area formula. Has anybody got it approximated yet? Let's do 2 decimal places. 6,949.3 what? And that's in square feet. Feet squared. Your second area, anybody got it yet? Should be 7,799.52 or 53 actually. Tack that on to the, and that's also in square feet. So there's your two areas. Add those two areas together, you get, let's see, plus 6,949.34, 14,000, or it's approximately 14,748.87 square feet. That's the two areas added together. Like I said, just out of curiosity, let's see how close we could have got to that with our trapezoid formula. Area equals 1/2 times the height times base 1 plus base 2. Where these would be our bases. So it'd be 1/2 times the height. Like I said, the height needs to be perpendicular. This is extremely close to perpendicular, so I'm going to use this for a height. 1/2 times 93.5. It's not going to be exact. Times base 1 plus base 2 will be 148.7 plus 155.4. And you get about 14,216.68. Not bad. It's fairly close, but you lost some area. So you could say, as far as approximating, you could say, well, that's nearly a trapezoid and use that to approximate it, but you're not going to get the exact answer. You're going to be about 500 square foot off. Next problem. Let's talk about, first off, bearings. It says the measure of an angle that describes the direction of a ray is called a bearing of the ray. It's kind of like airplane flight is where you hear it most of the time, or travel. They're at a 60-degree bearing, or whatever. In air navigation, bearing is given as a non-negative angle less than 360, measured in a clockwise direction from due north. So everything is based on due north. If you're at a bearing of 60 degrees, this is what it looks like. And this is going to be confusing because you're going to be, or I do, I think about your standard position for an angle. Normally this is your reference point, and you go this direction. Well, this is completely backwards. North is always your reference point when you're talking about bearing, and you're going clockwise from there. So a 60-degree bearing would actually be what we consider a 30-degree angle in standard position. 150-degree bearing looks like this. 225-degree bearing, you're traveling, that'd be southwest, a 45-degree southwest angle. I'll say that. Because the angle from here to here would be 45 degrees. If you're traveling somewhere up in here, like this would be like a 350-degree bearing. It's nearly all the way back around. But it's always a positive angle, and it's always based on due north when we're talking about these. So here's the actual problem. I just need to show that to you so that you know what I'm talking about by bearings. Here's your first problem. It says a Bush pilot left Fairbanks Airport, which is right here. Left Fairbanks Airport in a light plane and flew 100 miles, right there, 100 miles toward Fort Yukon in still air. What that means, we don't have any wind or anything. In still air on a course with a bearing of 18 degrees. And again, here's due north. An 18-degree bearings means take due north and go 18 degrees to the right. He then flew. Says she then flew due east. Does everybody understand why due east would be a 90-degree bearing? Here's 0 degrees. We measure it due east, straight east would be a 90-degree bearing. So she then flew due east at 90 degrees for some time, we don't know how long, to drop off supplies to a Snowbell family. After the drop, her course returns to Fairbanks. Fairbanks had a bearing of 225. And what they've done, they put these XY axes here so you can see the different bearings. So a bearing of 225, here's 0, 225 is how she's traveling back to Fairbanks. So there's your picture of what's going on. Well, we need to know what is her distance from Fairbanks is what we're looking for here. This problem is not as bad as it looks. All the numbers are just going to throw you off. You've got a triangle here, and we're simply looking for this leg of the triangle. We're missing some angles, but we can find those angles very easily. If this is 0 degrees, 90 degrees, 180, 225, this piece of the triangle, somebody know what that would be? 45 degrees. Because that would be, again, 180, 270. So the distance from 225 to 270, that's 45 degrees. Here you have an 18 degree, you see the 90 degree over there. From eastbound to northbound, that's 90 degrees. So if this is 18, they've done you a favor. I wouldn't have gave you that 45. But let's show you where that 45 comes from. It goes back to geometry again. Good geometry review. This is eastbound. That is eastbound there. This is eastbound as well. So therefore, those two eastbound lines are parallel to each other. Have to be. Anytime in geometry you see a Z shape, to where the top and bottom of that Z is parallel, you've got what's called alternate interior angle. You know that. 45 degrees and this 45 degrees are alternate interior angles. Those are always going to be the same angle. So that's where that 45 came from. So if this is 45, this is 18. What did you say this was? That's 63, so 27 degrees. I don't know if we're going to need that. Or you could have just done the 108, 45, adds up to the same thing. And then subtract from 180. That'd be 163 minus from 180. That'd leave you with, well, no, 153 from 180 leaves you with 27. So you could do it either way. So now that we've got all that, we didn't need all that, but now that we have all that, law of sines from previous lesson. The sine, let's start with our key. We know that this is 100 miles. So 45 goes across from 100. The sine of 45 over 100 equals, let's see, what are we looking for? The B, the sine of 108 over B. And that's how you're going to find that distance. So like I said, the problem's not as hard as what it looked. They gave you a ton of information. Excuse me. So you've got to solve this, you're going to type it in as 100 times the sine of 108 over the sine of 45. Get a decimal, and you're done. Now, as you're typing that in, if somebody would type that in for me, let me remind you that, again, ACT problem. They're not going to go through the process of typing all that in, but one thing they will do to you, you know the sine of 45. They will take, and if it's one of those common angles that you're supposed to know, sine of 30, sine of 60, sine of 45, cosine of 135, if it's one of those that you're supposed to know, they will plug that in. So what they'll do there is, you got 100 times the sine of 108 over square root of 2 over 2. Remember that? And then you could flip and multiply, and you can do all that stuff. Flip and multiply, that'll be 200 sine 108 over root 2, which will rationalize. This might clean up kind of nice. Multiply top and bottom by root 2, you've got 200 root 2 sine 108 over 2. Those will cancel and leave you with 100 root 2 sine 108. That's how they would leave that answer. Okay, so make sure that you remember sine 45, sine 60, all those common sine, cosines, and tangents. So has anybody got that typed in? 134.5 miles is how far you are from your original. And did you test it here? Because what I would do, if I get on that test and I don't remember how to simplify stuff, you've got your calculator there. Why not go ahead and work it out and get this 134.5, and you don't know which answer choice it matches up with, so what do? You take your 5 answer choices and you type them in until you get 134.5, because you know that's the right answer that match up. Awesome. Any questions? Okay. Next law, the law of cosines. And if you want to, you can write all 3 of these down. I wouldn't. All 3 of these formulas are the exact same thing. I'd write down one. A squared equals B squared plus C squared. Looks a lot like the Pythagorean theorem. Minus 2BC times cosine of A. That part does. A squared equals B squared plus C squared minus 2BC times cosine of A. Here's that relationship. So you got, here's angle A, angle B, angle C, side A, side B, side C. The reason I say all three of those formulas are the same thing, if you're looking for A squared equals B squared plus C squared minus 2BC times cosine of A. Well, what if I took and did this? What if I said, okay, this is no longer angle B, this is angle A, this is angle B, and that's angle C. Let's just leave that C. And that switched all the sides. You know what it's going to do to the formula? A will switch places with B. So everywhere you had a B, you put an A. C stayed the same. Does that make sense? A and B switched places. A and B switched places. It's the same formula. So if you just want to use this single formula, what you can do is if you're looking for angle A, but if you're looking for angle A, but you don't know that formula, you can just scribble this out and put angle A there in place and just swap places with it. It doesn't matter what you name the formulas. Okay, is what I'm trying to get at. Here you go, first problem, and I'll kind of show you on this one, or on these problems, what I mean by that. Given that, and which, by the way, I didn't go into this enough. Law of cosines is probably easier to use than law of sines. One of the main reasons is this. When you use a law of sines and you had to do that inverse sine, let's say you had the sine of alpha equals 1/2 is the example I keep using. We had two answers that fit that. We had 30 degrees in the first quadrant. We had 150 degrees in the second quadrant. We had two possible answers. What if it was law of cosines, though? Cosine of alpha equals 1/2. How many answers you got? One. Because if the cosine of alpha is 1/2, what angle is that, by the way? Root 2 over 2, 60. Cosine of 60 degrees is 1/2. Well, is there not another angle over here that would be 60 degrees as well? No. What's the cosine of this angle? Negative 1/2. So therefore, if you got a positive cosine, you're in the first quadrant. If you got a negative cosine, you're in the second quadrant. What about the third and fourth quadrant? You're not dealing with a triangle if you're in the third and fourth quadrants. So you can tell pretty much whether your angle is going to be acute or obtuse by looking at its cosine. So here we go. Back to this problem now. It says, given that A, B, and C, you got three sides of a triangle, find alpha, beta, and gamma. Law of cosines states that, we'll start with this, A squared equals B squared plus C squared minus 2BC times the cosine of A. So with this, we're looking for, obviously, alpha, beta, gamma is what we're missing. So with this formula, we're going to look for alpha first. A squared equals B squared plus C squared. A is 8.2. Remember, it's across from alpha. So you have 8.2 squared equals B is 3.7 plus C is 10.8 minus 2 times B, which was 3.7, times C, which is 10.8, times the cosine of alpha. Solve it. We're done. I mean, it's pretty much just plugging in and then solving. These are pretty easy. One thing I do want to caution you. Here's the number one mistake that people make. They'll do 3 squared. They'll do 10 squared or 10.8 squared. They'll add those together. Is that okay? Sure. Then they'll do 2 times 3.7 times 10.8, and they'll go ahead and subtract it. Is that okay? No. This stuff has cosine alpha attached to it. It's kind of like, let's look at it like this. It's kind of like 3 plus 4 plus 5x. I can do 3 plus 4, that's fine. But I can't do plus 5. This is the same type problem. You can do this part plus this part, but you can't subtract this because it has this x stuff attached to it. So be cautious. Here's how I actually work these, though. To type this into my calculator, watch how I type it in. Maybe this will help. Make these problems a little bit quicker. Clear? I got 8.2 squared I'm going to move over, because we want to isolate cosine, I'm going to go ahead and move over 3.7 squared. Whoops. I'm going to move over 3.7 squared and 10.8 squared by doing this. Minus 3.7 squared minus 10.8 squared. Go ahead and hit enter. Negative 63.09. So I've got negative 63.09, and I usually don't write this down. I'll go ahead and do the next step too while I'm at it. Negative 2 times 3.7 times 10.8 times the cosine alpha. Well, how do I get rid of this stuff? How do I move that stuff over? You divide. Since it's being multiplied by cosine, I'm going to do divided by, and you got to be careful. Make sure you put it in parentheses. I'll show you why. You might already know it. If you don't put it in parentheses, what's it going to divide by? Just a negative 2. It'll do that answer divided by negative 2, and it'll take that answer and multiply by the others. So you need parentheses because you want it to divide by that whole thing. Second, insert parentheses. And you get 0.789. I've got an acute angle. I've got a first quadrant angle because I now have the cosine is equal to, I move this over, the cosine is equal to 0.789, so to get rid of cosine, we do second cosine of the answer, 38 degrees. We'll call it 37.9 degrees. Alpha, 37.9 degrees. And do this. Store into alpha A. You'll see why in just a second. I had to use law of cosines, and here's always my rule. When do I use law of sines? When do I use law of cosines? I think I told you, hit on this the other day. You use law of sines every opportunity you get. Law of sines is a lot quicker. I couldn't use law of sines there. You could try sine of alpha over A equals sine of beta over B, but you've got two unknowns there. Did you see what's going on now? Now I know alpha, and I've got a key. I've got alpha and I've got side A. Now I can use law of sines. So if you need all three angles, you got all three sides, you need all three angles. First step, you'll have to use law of cosines to find one of those angles. Now that you have one of those angles, look, sine of 37.9, which I have stored, and you see now why I have it stored. I want the exact answer. I want to use exact to find my next answer. Sine 37.9 over 8.2 equals the sine of it really doesn't matter. Let's do beta next. Sine of beta over 3.7. To solve that, we got to do 3.7 times sine of 37.9. So 3.7 times the sine of 8. Let's see why I said it now. Divided by 8.2. Gives me 0.27, That tells us what sine of beta is because I moved everything over except for sine beta. To get rid of sine, we're going to do inverse sine. So we do second sine of the answer. Gives me a 16-degree angle. So we'll call it 16.1. So beta, 16.1 degrees. But remember when we use law of sines, we've got to be careful because what if there's another answer? The sine of beta, or you do that inverse sine and you get beta 16.1, it could be 16.1 or it could be, I think that'd be 100 and, let's see, supplementary, 163.9. Yeah, and that's not going to work, right? Now you got to be careful. What if it's not drawn to scale? But there's two reasons that we know this will not work, and I've explained both of them. Number one reason, 163.9 and 37.9 will not jive. Right? That's already over 180. The second reason it won't work, look at your side lengths. 3.7, 8.2, 10.8. The largest angle will always be across from the largest side. This can't be 160-something degrees because that's actually the smallest side of the triangle. It's not going to be bigger than 37.9. So 16.1 is the only one that will work. So there's two of your angles. Now, do we use law of sines again to find the third angle? I would. The three angles of a triangle always add up to 180 degrees. 37.9, 16.1 is equal to 54, which leaves 126. Double check me on that. 126.0. 53, 54, that's right. Yeah. Okay. Why do I put 0.0? This is just one of my own personal little things. If you put 126 degrees there, if you saw 126 degrees, wouldn't you think it's exactly 126 degrees? The reason I put the 0.0 is to kind of red flag to people, that's not exact. That's a rounded 126.0. It might be 126.03 or something like that. It's called significant digits. We'll talk about it in science. Next problem. We'll stop after this one. The wing of an F-106 Delta Dart is triangular shaped with the dimensions given. Find the length of the side labeled C. Don't you love this? That pretty much it has absolutely nothing to do with the airplane. It's just find the side. Okay, they could have just said find the side, but they wanted to make it a little bit more interesting by talking about airplanes. So here we go. Got a 68 degrees. You got two side lengths here. You could try to use law of sines. You've got an angle. The sine of 68 over C equals. There's nothing else you can do. So that goes to show you why you use law of cosine instead of law of sines, because there's nothing else you can do with that. We can find the area of it, by the way. See the side angle side relationship? You could find the area of this by using that area formula, but we're asked to find the side length of C. So here's the formula. Now, I've got a problem. I've only memorized that first formula. You see where I'm going with it now? The only formula I know is a squared equals b squared plus c squared minus 2bc times cosine A. It's not really, but let's just say this. Let's say that's the only formula I know. Well, there's only one angle that I'm given here, and it's angle C. So what do? I call it angle A. I call that side A. So now you can use it. Okay. If you just want to memorize one formula, you can always do that. You can just rename your side lengths and do whatever. But it's really easy to change from that. What if you wanted to change this to cosine C, where you just change all the A's to C's and all the C's to A's? It's the same. So here we go. We're looking for side A. So we have a squared equals b squared, and we'll say this is b and this is c now. B squared would be 19.2 squared. Plus c is 37.6. Minus 2 times 19.2 times 37.6 times the cosine of 68 degrees. I'm going to move all that over. Well, I'll just write it below. Cosine 68 degrees. Guys, we're solving for A. You can type that whole thing in your calculator. And to save yourself another step, why don't you go ahead and get rid of the squared while you're typing to the calculator? That makes sense. How do I get rid of a square? Square root. So what I would do is I'm typing this in to save even more time is go ahead and do the square root of all that. The square root of 19.2 squared, which by the way, stopping there, that would be 19.2, but since you have all those plus and minuses, you can't just take away squares. Okay. Square root of 19.2 squared plus 37.6 squared minus 2 times 19.2 times 37.6 times the cosine of 68. Typed it all into my calculator, 35. 35.2. Well, no, I went ahead and typed in. That's what I was to save yourself a step. See how I typed it in? I went ahead and did the square root as I was typing it. That way, now it gives you A. So I did this. I marked that out and did that whole square to the whole thing. You can, I mean, if you just want to type it straight in and then square root after, that's either way. So A is about 35.2 feet. And here's a good way of catching that. A lot of people will work that problem out, and they'll get this, 1,241, and they'll say this is equal to 1,241. So that's 19, that's 37, and this is 1,000. Does that make sense? Always go back and ask yourself, is my answer reasonable? Because if you'd got 1,241, it would have been red flag. I need to do something else. Something's missing. You know, what else was I supposed to do? But then once you get 35.2, does that look reasonable? Well, if this is 37, then if that's drawn to scale, that looks to be a little bit shorter. I'd say, yeah, that's a pretty reasonable answer.